Morning, everyone. I'm Chris Lopez, and I'm going to be talking about today how NetBrain can provide end-to-end visibility and automation for Cisco ACI deployments. It's been nearly 2 years since we updated how NetBrain can discover and manage ACI, and there have been a lot of cool features added to the software in the interim. Data centers are a whole new world compared to a couple of years ago, and many people are buying into the idea of operationalizing their data center with code. Odds are, even if you're not currently implementing it, your organization has at least considered an ACI deployment. In this session, we're going to be going over how NetBrain can interact with both SDN and legacy environments and get a sense of how our solution would impact your day-to-day operations with Cisco ACI. Excuse me. Let's get started. First, let's talk about why you're even considering SDN in the first place. Industry changes are impacting almost every level of IT, and that includes applications. Their life cycles are broken into smaller windows. Applications are less structured thanks to hypervisors like ESXi and containerization tools like Docker and Kubernetes. There's a burden on the network to keep up with demand and contribute to a more successful business service, and it requires change in the way that networks are built and operated. It's likely one of the main reasons you're looking at Cisco ACI is for its scalability and its agility. In other words, how ACI lets you expand infrastructure in a way that doesn't create a lot of expenses once you hit a certain threshold. If you're in a position where you need to increase service output but your network is maxed out, ACI makes a good case for just adding more spines and leafs into the mix rather than tearing out your existing bare metal devices and putting in new ones. Top-down control is also an essential aspect of ACI, right? Manual changes don't cut it for an enterprise deployment anymore, especially if you need to modify configurations device by device. The ability to push sweeping network changes with just a couple of lines of code shrinks a maintenance window from hours or days to just a few minutes. And finally, as I'm sure you're aware, successful ACI deployments are associated with fiscal savings. The unit cost of providing a service, right? The hardware, the power, associated costs all become cheaper in the long term with an organizational cutover to an SDN solution like Cisco ACI. A properly configured SDN deployment can beat the service cost of a traditional network by nearly 40%, and it allows organizations to avoid being hit with expensive growing pains as their business evolves. And there's a lot of reasons why we want to love SDN. The truth is that solutions like ACI can be very powerful in the right hands. But there's also issues that people overlook until they come up, right? And these are things that prevent software-defined networks from capitalizing on all of their strengths. Abstraction is great when things work out, but not when they don't. There are new types of issues that people encounter when they transition into an ACI deployment, and they're not as talked about as they should be. For starters, unless you're training your entire team on Cisco ACI at once, there's going to be a knowledge gap between your SMEs and the rest of your NetOps guys. If new ACI issues come up and you're the ACI guy, odds are you're getting most of the trouble tickets related to it. Your team will probably have limited experience with the new technology, and this gap is going to lead to slower incident resolution and solving problems without meaningfully passing on know-how, right? Which is going to keep you solving the same problems over and over again. Changing in technology type is going to be adding complexity to a network. Once you've mastered the art of defining endpoint groups, contracts, interface policy groups, and whether you want a fixed or a modular spine architecture, right? Your network traffic is eventually going to pass through a legacy edge, and that's going to create a new point of failure in the network. This complexity means that you can't monitor or visualize application dependencies the same way that you used to. If you troubleshoot across an ACI environment, the path is likely going to break as you cross into legacy devices and vice versa. And finally, when it comes to day-to-day operations with ACI, troubleshooting has the same kind of issue. If you need to diagnose the root cause for a slow application, you're going to need an automation platform that can go beyond provisioning and change management. Like I mentioned before, one of the greatest benefits of ACI and SDN in general is the top-down control of an entire network. This kind of control is very useful if you know what you're doing and you know what you want to build or change. But if you don't know those things, then that kind of automation isn't going to be as helpful. One issue that ACI doesn't address is how engineers often resort to manual operations when it comes time to diagnose new issues, right? Most of the investigative work is still going to be done manually and often with trial and error. So what more do we need? That's the big question. Well, first, we're going to need a system for encoding and reusing know-how. This relates to the knowledge gap that I was just talking about. If you have the idea or if you have the ability to take all of your best practices and operationalize them in a way that like you can hand a booklet or you can hand a file to somebody and say, hey, this is how you troubleshoot your ACI environment, then that's going to be extremely useful for up-leveling all of your junior operators and letting everyone work independently. The ability to proactively teach the rest of your team about how ACI works and how it looks in relation to the main, to the rest of the network is invaluable. We're also going to need a network agnostic management platform. So we're going to need something, like I was saying, that can interoperate with both an ACI environment and with a legacy environment in a way that's not just provisioning and change management. You're going to need CLI level, a service level access to all of your devices. And you're going to need a tool that's going to help you manage and execute diagnostics across both of them. And speaking of diagnostics, you're going to need automation for your day-to-day network operations, not just in terms of providing visibility between your ACI fabric and your legacy edge, but also being able to tell you the results of commands that come out of these devices. In this sense, all three of these needs correlates in some way or another to each of the problems, or each of the software-defined problems that SDN ends up bringing into a new deployment. And here's where NetBrain helps. We're able to pull, using a RESTful API, all the relevant data in from an APIC. And we're going to be able to also pull similar data in from your traditional network. So we're going to log in, in a traditional network, we're going to have a service level access to your CLI. We'll pull your configuration files. And then with the Cisco ACI fabric, we'll just need a REST, we'll need a REST API connection, and we'll be able to pull everything from the APIC, like I was saying. And we can turn this all into a data model that honestly, most tools aren't able to do these days. Only really NetBrain is going to be able to interpret data from the comprehensive hybrid network and give you a platform to be able to execute mass changes on top of it and also run mass diagnostics on top of that as well. We're going to be able to help you in the following ways. You can map a heterogeneous network. So you can take your fabric and you're going to be able to add neighbors to the map until you reach your layer 3 deployment or the rest of your legacy network. You're going to be able to create an end-to-end path of a hybrid application, meaning that you're going to be able to trace where it goes through a spine and a leaf, what contracts it hits along the way, and then finally what happens once it reaches your layer 3 and your legacy devices. And then finally, you're going to be able to automate diagnostics on top of it, meaning you're going to have runbooks that are going to be able to touch each of these devices, execute commands, and then visualize that data for you directly on the dynamic map. So over the course of this webinar, we're going to be going over ACI functionality in 3 parts. It's going to be visualizing a hybrid environment, automating a hybrid environment, and migrating from a legacy environment. So I'm going to break this down into just a series of questions that you need to ask yourself while you're troubleshooting. All right, so we're going to start with some issues with ACI visibility. What are the problems here? You can't see beyond the technology edges. Mapping applications is more complicated, and the network itself, the technology that you're operating on, has fundamentally changed. So this creates a visibility issue, meaning that you can't see the gap between your ACI environment and your legacy environment. Figuring out what dependencies your application crosses is definitely a more involved process. And the network is fundamentally changed, meaning you can't just go into the CLI of a specific device and then execute a few commands. Troubleshooting is different. Now, here's how NetBrain helps. How is my fabric configured? Well, you can visualize multi-pod and contract views inside of NetBrain. How does this work with my legacy environment? Well, you're going to be able to document the hybrid network in a dynamic map. And what does my app look like? Well, you're going to allow you to path across different technologies end to end. And let's see what this looks like inside of NetBrain. This is where I'm going to be able to see my Cisco ACI deployment. So I can actually look at this in application-centric view or in a network-centric view, like a fabric or a tenant. I'm going to start here inside of network-centric view. I have 2 multi-site deployments with ACI here. And I'm going to go ahead and just select one pod just to start this off. Now, when NetBrain discovered this, it was able to pull in, as I mentioned, all of the relevant data from the APIC and related to this pod. So when I open this map, I'm going to see 3 spines and 2 leaves and a number of red plus marks above each of these devices. Now, this is useful because this is visualizing your pod. But if you need to be able to get more information, or if you want to be able to see how this interacts with the rest of your environment, all you need to do is click on the red plus button and begin adding neighbors to your environment. So I'm going to go ahead and add ACI L3 out. And now here I've added a layer 3 switch, and I'm going to go ahead and add more neighbors on top of that. So I have some checkpoint firewalls here and high availability. And I've now added those to the map as well. And here we've got a hybrid map now, right? We have ACI fabric here. We can see where it extends, and we can go out here to a couple of firewalls and even beyond that if we wanted to. With this, NetBrain's going to give you visibility on every aspect of your network because NetBrain is able to reach and manage all of your devices, regardless of what technology level they are. Whether it's cloud or VMware or ACI or SD-WAN or just legacy devices or virtualized, and NetBrain is going to be able to provide you similar levels of access and control for each of them. So with this is just an example of pulling legacy devices onto a hybrid map. I'm going to go ahead and go into application-centric view now. I'm going to go ahead and make a new map here. Now, this isn't just dealing, NetBrain isn't just able to visualize one pod. NetBrain is also able to visualize multi-sites. So I'm going to go ahead and just show you this, this one site here. This is a very large SDN deployment. I had multiple APICs, many spines, many leafs, and some IPNs. And if I wanted to understand how this worked behind the scenes, I have the ability to do this. So I'm going to go ahead and go into application-centric view, and I'll click on this one tenant here. And I'll go for this, this quality assurance app. Now, this is just one app inside of this fabric, but it's going to be represented in terms of contract view, right? So we're going to be able to see endpoint groups that currently exist. We're going to be able to see contracts that negotiate how traffic is routed on the network and where we're going to be reaching layer 3 outs, whether it's an external network or an ASA firewall. You're able to abstract your ACI deployment into like a series of logical flows like this. So this way, engineers who don't have a lot of experience with ACI are able to look at this and say, oh, I understand what this is doing now that we've broken it down into the context of legacy devices and things, of endpoint groups, of policies, and things like that. So with this, I'm going to move on to the final part, which is mapping a hybrid application. So here, if I go into the path browser, I am now going to draw a hybrid application. So from a multi-pod SDN path. And what we're going to see is an application that's starting from a web server, passing through a ACI fabric, and eventually ending up at a legacy environment. So if for some reason I have some application that relies on this infrastructure and I need to start troubleshooting it, I have an end-to-end map of every device that it touches along the way, which I imagine is going to be very useful for people who are trying to troubleshoot an inherently more complex environment now. Now we're going to go into automating a hybrid environment. So this is the second part of it, right? This is not just about figuring out what it looks like. This is about figuring out what's wrong. And if you're in a ACI troubleshooting instance and you have to deal with a larger, heterogeneous environment, you're going to notice a few things. One, any automation tasks that you have are going to be breaking into technology edges. So things that you use to troubleshoot ACI are going to be different than the things that you use to troubleshoot a legacy environment. As a result, comprehensive network data is also going to be scattered because a lot of tools are going to have information and they're not going to be in the same place. You're going to have a lot of your ACI fabric data inside of your APIC. You're going to have monitoring data and other, like SIMs and other like NetFlow and IPFix and JFlow tools looking at your legacy environment. And a lot of them are, this is going to translate into you hopping through a bunch of CLIs, a bunch of tools, and a few other, a few other panels until you figure out what exactly is going wrong with your network. So here, finally, we have a knowledge gap among your teammates, right? And this is what I was talking about in the beginning. Who really knows how to troubleshoot an application from an ACI end to a legacy end? And the answer is probably not all that many. Well, here's how NetBrain helps. How do I fix a hybrid application? Well, you can automate best practice diagnostics for your hybrid network using NetBrain's executable runbook technology. What do my other tools say? Well, you can pull network data onto the map from the APIC and the other solutions. And how do I modify this fabric? You can push changes to the APIC with NetBrain's Ansible integration. And with that, I'm going to go ahead and hop back into an instance of NetBrain, but I'm going to start at a slightly different place than before. So this is a similar application, but I'm just pulling this up in terms of the ACI fabric environment, and then we're going to hop into the hybrid environment. Here, we can see that a recent path that we've run has failed. We started at a web server and we've ended up at NBLE4, and there has been a failure in it reaching the end of the, the other end of the critical path, and we don't necessarily know why. With NetBrain, we're going to show you how easy it is to troubleshoot a hybrid environment. So inside of here, I'm going to go ahead and start executing some data view templates on top of each of these devices. So first, I'm going to start off by pulling data from the APIC for fabric underlay connections, right? I wanted to decode for me, what is my L2 out, what is my L3 out, what are, what addresses get translated, and what do I need to be aware of? So simply by clicking this, NetBrain makes a separate API call to the APIC, and it's able to pull all of the contextual data down onto the map. If I zoom in, I'm going to be able to see, hey, we have these VRF overlays. We're going to tell you what interface they're associated with. Down here, we can tell you, L3 and L2 borders. And really just giving you a lot of rich contextual information regarding the APIC before you continue on. And just to point out, we also have some legacy devices over here as well. So I'm going to start running some data view templates that are going to look at the legacy devices, like the overall health check, which is just looking for common indicators of performance issues, such as input errors, output errors, CPU and memory utilization. And it looks like we have an alert here at ACI L3 out. I'm going to go ahead and check this out real fast. Just some high CPU usage, nothing, nothing to get too worried about. And down here at US Boss switch 2, it looks like these are fine as well. We're also able to pull in, not just from the APIC, but from your other tools, information, such as if I had a instance of PRTG, I'd be able to execute a data view template that pulls in all of the sensor data that's associated with the legacy devices. Or if I had SolarWinds and I wanted, the APIC health report down onto the map, I'd be able to pull this as well. Also, if whatever tools that you have, whatever third-party tools that are necessary to your troubleshooting operations, you're able to put those and all the information you get from them in the context of a NetBrain map. So that way you're not hopping through a bunch of tools to do your job. And down here, I'm going to point out that this alert here, the CPU usage, is actually a it's a statistically recorded variable. So over here, I'm looking at something called the golden baseline, which is where NetBrain records nominal network, nominal network behavior. And here it says our golden baseline range is roughly 30 to 37% CPU usage, and it's hitting 38. So it's giving us a time-lapse graph of exactly how this variable has been behaving on our network. Hopefully with this, you're able to see just some of the information and some of the possibilities that NetBrain can provide you. Obviously, we won't be able to go over every ACI instance today, but we're able to show you how NetBrain is going to be able to help you and your team troubleshoot these instances much faster, especially with recommended actions. And this is one of the main ways that we are able to bridge the knowledge gap, not just by visualizing the hybrid network in the context of a single holistic application, and not just within the data view templates that are able to execute automation tasks on a large scale, but the recommended actions are going to be there, they're going to be recommended by the person who created this data view. In this sense, think of it as a senior engineer who is then recommending new automation tasks for me, the junior engineer, to utilize across my environment. And whatever I recommend here is I'm going to be able to add it to my runbook. So here, we can do show log and include input, or show run section and include certain inputs. And maybe I want to pull up BGP information as well. I'm going to be able to do that because NetBrain is able to execute this across all of these devices at once, regardless of their vendor or technology type. So with this, I'm basically going to continue troubleshooting. I do want to point out one thing, which is NetBrain is going to be able to provide some deep contract views for each of these devices. So if I go back into here and I click on view details, and I go to the leaf switch that failed to path, I can go down here and actually check the ACI contract. And it's telling me from the external endpoint group table, it's been able to, it was looking for matched entries, obviously, but it wasn't able to find a matched entry for the protocol that I was attempting to push through, which is, port 8000. And this is giving me a sense of what I need to be modifying about this network in order to restore my service application back to normal functioning parameters. So I'm going to go ahead and execute a change here real fast. I'm going to go I'm going to go ahead and execute a change, and I'm going to add a ACI contract, or I'm going to add a change to an ACI contract using Ansible. So over here, I'm able to define what Ansible playbook I'm using. I can actually pull it in from a repo or some other kind of or some other kind of SCM manager. And once I have this, and once I have it approved, I'm able to push this change to the contract filter directly onto the APIC, which is going to let me have access on this port number in the future. So here, I'm just going to go ahead and approve this, and then I would execute it. And once that's done, and once the APIC refreshes, I'm going to run a path again, and we're going to see how this application has been restored. Okay, so now that I've defined this change, the Ansible task itself has been locked, so I can't change anything about it. It's going to pull information from the inventory once I execute it, and we're going to go ahead and run it. So what's happening here, as I mentioned, is we're using Ansible to push a change to the ACI contract filter. And once that's done, I'm going to verify that the application that I've been testing here does function as normal. So one of the biggest benefits that you can see here is, again, NetBrain is able to touch each of these devices and execute a number of diagnostic commands, which is really going to be saving your team a lot of time when it comes down to troubleshooting a network issue, especially one across a hybrid environment. All right, I'm going to go ahead and run verify application. It's an automation task that we have that's going to allow us to define our applications in the context of A to B paths, and we're going to go ahead and run this path and make sure that it's still up and it's still operational. Looks like we still have a failed result here. Let's go ahead and draw this on the map. Well, we're able to see that this path still doesn't quite work the way we want it to. There is something else that I'm going to need to take a look at in the future, and we don't have time to really linger on this now. But hopefully we're able to see how NetBrain is able to traverse from point A to point B, and able to give you some deep visibility across all of the devices that you are currently need to manage on a regular basis. So with this, I'm going to end the second demo. So last bit here. So even if you don't necessarily have SDN, though, based on that first polling question, looks like a lot of you are already operationalized. Here, we're going to talk about migrating from a legacy environment. So even if you don't necessarily have NetBrain loaded up right now, even if you don't have ACI loaded up right now, NetBrain's going to help you migrate from a legacy environment over to a software-defined one, just in a couple of ways. One, it's going to help you ease the learning curve for ACI, using all the methods that I just showed you in terms of the hybrid visibility and the automation and the recommended actions. But it's also going to help you decode underlying network design. And that's going to help you map all of your application dependencies in the context of IP addresses, in the context of security policies, in the context of your 5-tuple that you need to translate onto an ACI fabric. And with that, I'm going to hop into NetBrain real fast and show you just real quick what that would look like a little bit. So I'll go into the physical network, go to the United States, and I'm going to open up a new sitemap. This is going to be a legacy one. So over here, you can see that we have a couple of routers, a few switches down here over to a few web servers. And if I wanted to, I would just start, if this was something that I needed to translate into an APIC, I could just go in and execute a few data view templates that are looking for routing information. So I can go ahead and pull up EIGRP and BGP overview, so that way I can start getting an idea of what my endpoints need to be. I could go in and start checking my access lists, so I could make sure that the traffic is being sent in the appropriate way. And I'm able to pull in, again, just whatever I need from each of these devices' configuration files in order to effectively mimic it inside of a software-defined environment. So the way that this, I could turn this map into a map that you would then see like the contract view I showed you before. So we'd be able to take all of those rules and all those rules and IP addresses that are present here, and we'd simply be able to turn them into an ACI fabric map, but also a contract map showing you the logical flow of traffic between point A and point B. All right, and that's just a real quick example. I'm not going to go too much further into that. So wrapping up, NetBrain is going to help you improve ACI migration pardon me on that one. It's going to help you decode and translate existing application dependencies, and it's going to help you proactively approach the ACI learning curve. It helps you improve visibility with NetBrain, helping you visualize single or multi-pod fabrics and contract views. It helps you create hybrid maps and extends to legacy environments, and you can path through technology edges and see critical application dependencies. Finally, you can improve ACI operations with NetBrain, allowing you to access and diagnose your systems simultaneously, encoding and reusing know-how from your subject matter experts, and you can push changes from one console.